Morning. Today we are going to talk about the law of signs again, but today we are going to discuss the ambiguous case and what the ambiguous case would imply, and when it would occur, and how to complete solving a triangle with an ambiguous case. The video hopefully won't be as long as the first one, but please make sure you are pausing as necessary to get information in your notes and comprehend what is being talked about. So let's start, just like we did last time, with some prerequisite knowledge from the past. So our first question is, which quadrants is the sine function going to be positive? So we know we have our four quadrants. We also know earlier this year we learned about all students take calculus. And as we go around the four quadrants, all the functions are positive in quadrant 1. But then we have the sine function positive in quadrant 2, the tangent function positive in quadrant 3, quadrant 4, cosine's positive. So they specifically say which is the sine function positive. Well, that would be quadrant 2 and quadrant 1. And keep in mind, the pole on the left is 180 degrees. Once we go into quadrants 3 and 4, those are past a rotation of 180 degrees. And since we are talking about triangles, these quadrants will never apply, because we can't go past 180 degrees in a triangle. So quadrant 1 and quadrant 2 are where the sine function is positive. Which takes us into question 2. What are both angles that satisfy for the equation? Sorry about my grammar there. So we've got sine of x equals 0.2. And we are looking for x, and x is the angle. So sure enough, if we break out our calculator, and we do inverse sine, make sure you're in degree mode, and you put in 0.2, you will get an angle measurement. And that angle is 11.5 degrees. Okay. So the inverse sine of 0.2 is going to give us 11.5 degrees. However, that only satisfies quadrant 1, because the calculator's inverse function only ever talks about degree rotations between 0 and 90. So this 11.5 would be over here. But we also know from earlier this year, the sine function can be positive in the second quadrant as well. So the reference angle would be the same. It would also be 11.5. But as far as the rotation from 0 into quadrant 2, how far is that? Well, this is going to be supplementary. Supplementary angles add up to 180 degrees. So if we take 180 and subtract 11.5 degrees, we will actually find the rotation in quadrant 2. And that would be 168.5. So that angle and 11.5 degrees both satisfy the function sine of x equals 2.2. We just have to learn that we just can't always trust the only answer that's given to us on our calculator. Much like when we solve a quadratic equation and we do a square root, we have to always remember that it's plus or minus. So today we will be adding this concept back into our knowledge to help us with the law of sines and solve these triangles. Yesterday, we discussed oblique triangles, and we did the law of sines. This is kind of the one that I usually use more often, but they are the same thing. Remember, the capital letters are the angles, and the lowercase letters that are opposite those capital letters are the side lengths that go with them. So angle B inside B, angle C inside C. So what is an ambiguous case? The ambiguous case basically means that with the information that was given to us, there may be the possibility of more than one triangle, especially if the picture is not drawn for us. We don't know if all angles are acute or if one of the angles is obtuse. Ambiguous case is only going to happen in a side-side angle triangle, or better known as the ass triangle. So in an ambiguous case, you can expect 3 different scenarios to come into play. The easiest one is one triangle, which basically would just be what we were doing yesterday. Second possibility is there's no triangle, and with the information that they gave us between the angle, the side, and the side, one of those sides technically isn't long enough to complete the triangle. And there's a triangle inequality that you can go up and research to decide whether something's a triangle, but we won't need that. We're going to use the law of sines. And then the hardest thing to watch out for is there are potentially 2 triangles. And that's because the angle that they gave us, could also be supplementary with another angle in a triangle. Okay, so we'll talk about how can we find these 2 angles for these 2 cases as we go through today. Okay, but this is the one you're really going to want to focus on and make sure you understand what's going on. Being organized is going to be very helpful. Okay, but let's just continue to talk about how we can set up for this situation and figure out what these angles are. So once again, we're going to come back and we're going to discuss this. We already discussed in the warm-up that the output of the sine function is positive in both quadrant 1 and quadrant 2. So something that we would have seen in the past is we would have gotten reference angles of 45 degrees in both quadrants, but we needed to figure these out. Okay, we have our unit circle, of course, but not everything is going to be in the unit circle. But the idea is, in quadrant 1, the rotation is 45 degrees. In quadrant 2, the rotation is 135 because that is the supplement of the 45 degree angle. So supplementary means that we take 180 minus the angle. So 180 minus 45 gives us that other angle in quadrant 2 of 135. Okay. And if you kind of transpose this onto here, this is the reference angle, and then this is that big rotation from here to here. And essentially what this creates is this triangle is based off of that information, and then we just have the acute triangle from quadrant 1. So take a moment, kind of digest that picture. It definitely is a little complex, but really we have 2 triangles stemming from the information in quadrant 1 and quadrant 2. This is the one that we have to find the supplement of. So let's just practice that idea on its own. So if we have reference angles that are 55 degrees, well, we know that one of our angles is going to be 55 degrees in quadrant 1. And in angle 2, to find out that green line there that I just drew in, we're going to have to take 180 minus 55. Because what's going on there is this is 55. We're looking for that. So if we take 180 minus 55, when you're just getting back into the gist of things, make sure you're doing a calculator to double check your calculations. You don't want to be 10 off, which is very common. And you get 125 degrees. In example B, we have an angle in quadrant 1 that's 15. The second angle is going to be the supplement of 15, so 180 minus 15. Just double check. The answer is 165. It is very easy to just say 155 or 175. Miscarrying is a 10 digit over. So we will be using this concept in our ambiguous case scenarios. All right. So here we have some information that they gave us. They gave us A, B, A. Remember, the capital letters are our angles, though. This is our lowercase side that's opposite that. So based on this information, you want to kind of think about, okay, did they give us SSS? Side, side, side. Did they give us ASS? Did they give us SAS? What type of thing did they give us? Well, they gave us an angle and an angle and a side. So this is angle, angle, side. The question is that ambiguous? No, it's not. The only time you'll have an ambiguous case is if you have an ass triangle. Also note, it is very important that there is always a corresponding angle and side pair. We saw that yesterday with our law of signs problems. Moving on to example 2, we do have a corresponding pair. We have angle B and side B, so that's good. But this is an angle, a side, and a side. And yes, this is ambiguous. So if this problem we were trying to solve and find all the angles here, we would want to make sure that we do check for 2 triangles or no triangle. Question 3. We do have a corresponding pair again. Okay. And it is an angle, a side, and a side again. So yes, this is ambiguous. And then here, we do have an angle, a side, and a side again, but this one's not ambiguous. And that's because there's no corresponding angle and side matching. If we were to draw this out, remember, go around clockwise. This is A, this is B, this is C. And if I highlight the ones they gave me, when you come up with a name for a picture, you want to make sure that you're going in that clockwise or counterclockwise notion. So according to the picture, this is actually a side, an angle, and a side, which also supports why this is not ambiguous. The only time something is ambiguous if it's an ass triangle, and you can easily tell that from the picture. Okay? An ass triangle will always have the corresponding pair. If we draw this picture in example 2, we have our angles, our sides, and if I highlight the ones they told me specifically, you can see that this is a SSA in that order, or ASS as you go around. So it's important to know when you have an ambiguous case. Now, let's do some problems. Being organized is very key in these problems. The better you can stay organized, the easier it's going to be. You'll notice I gave us 2 answer blanks. This would technically be for triangle 1. This guy would be done for triangle 2. If we need triangle 2, that is. You won't always need it, so you may just have to leave that blank or cross it out. So let's label our information. We have triangle XYZ. The side length of X is 23.5. Y is 9.8. And X is 39.7. Let's draw this out. X, Y, Z, little x, little y, little z. So they gave me angle 39.7, and by they I mean I. X is 23.5. Oh, that's good. There's a corresponding angle side relationship. And they also gave me y is 9.8. So this is actually going to be what we want to find first, because we can need that angle. Okay, so let's set up for angle y. And noticing I'm labeling where I'm going to put my work to kind of help me follow what's going on. So we're going to set up our law of sines. So sine of angle y divided by the length of y is equal to angle x, so sine of 39.7 divided by 23.5. And we'll set up our proportion. Multiply the sides we know and divide by the last one. So sine of y is equal to 9.8 times sine of 39.7, all divided by 23.5. We will have to inverse this as well. So remember, alpha y equals, to bring up the fraction box, 9.8 times sine of 39.7 and 23.5. So 0.266, and this should be an angle, but we haven't done the arc yet, arc sine, the inverse sine of it yet. An angle measurement should make sense. It should be between 0 and 180 degrees. So inverse sine of the answer is 15.4. And we can go and write that in. Now, if there is going to be a second triangle in this ambiguous case, we would want to start by finding the supplement of the angle that we found first with the law of sines. So that's going to directly lead us into there. But that angle will be 180 minus the triangle's angle in triangle 1, so 15.4. And that's 164.6. Now keep in mind, the information that they started you with of 39.7 also applies. So does 23.5. So does 9.8. But now if we think, does this triangle exist? We have an angle of 164.6. We have an angle of 39.7. If we were to add those angles together, 39.7 plus 164.6, $204.3 is their sum, and that's greater than 180 degrees. Therefore, there is no triangle that exists. It's too great. So we don't need to finish that information at all. But this is where we find that supplement, going back to that prereq skills. Let's go back and focus on triangle 1. So we're going to find angle Z. And since I know the other two angles, I can just take 180 and subtract the angles. And that will give me 124.9 degrees. And then last but not least, I'm going to set up another law of sines to find side Z. So sine of the angle 39.7 over 23.5 is equal to the sine of 124.9 in angle Z divided by side Z. Set up our proportion. We're going to multiply 23.5 times sine of 124.9, and we'll divide by that. You will do this so much in terms of solving this proportion like this that it's just going to become second nature to just type it into your calculator and not necessarily show that work. Alpha y equals 23.5 times sine of 124.9 all over the sine. And keep in mind we're looking for a side length, so this is actually the side length. Z equals 30.2. Oh, one more thing we should probably mention. the only reason we had to check for the second triangle was because of the angle side-side relationship. Okay? That's when you're going to have an ambiguous case. Let's check out example 2. They told us a side length of 15, side length of 28, and 43.6 for our angle. We do have that corresponding side angle relationship. Let's draw it out and see if it's ambiguous. It's looking like it is. This is 15 because that's across from 43.6, and B is 28. And it is an ASS situation. So let's find angle B first. So sine of 43.6 and its corresponding side, 15, equals the sine of B over 28. Multiply your side lengths you know, and then divide by the third. And this is going to require an inverse. Sorry, I'm trying to get a good alpha y equals 28.5, or no, just 28, my bad, times sine of 43.6, all over 15. Get 1.28. And then we'll inverse that, we'll arc sine it. And we get an error. And if you read the error, it says domain error. And that's because the sine function's range is only between -1 and 1. The radius of the unit circle is only 1. So if I go past 1.28, that radius length is too big for the unit circle. It's not in the realm of possibility here. So this is an error, which means I can't have an angle, which means I have no triangle. Well, that was a nice, quick, and easy way to finish that problem. We don't have to even go through and check for that second triangle in that case. And our last problem today will involve an ambiguous case as well, but this one will actually have two triangles to worry about. So if we label our side lengths, we have 15, we have 20, and we have 29 degrees. Okay, we have that corresponding pair. This will be an ASS triangle ambiguous case. You'll notice I always do ABC like that. That's fine. Okay. So we are going to find C first. I'm also going to put a box around C. Now, I wouldn't know that this is actually going to be two triangles. You wouldn't know if it was any other problem, but it's going to be because we need to talk about one of those. So let's set up our law of sines. Sine of 29 over 15 equals sine of C over 20. Multiply 20 times sine of 29 and divide by 15. I'm just going to do that off screen here. Alpha y equals 20 times sine of 29 degrees divided by 15. And that gets me 0.64. And if we take the arc sine of that, then we can figure out our angle measurement. All right. So the supplement for triangle 2, angle C, is the one that we're going to have to find the supplement of. So we'll take 180 minus 40, and that's simply 140. Okay. Let's finish up triangle 1, though, before we go on. So angle A, we're just going to use our triangle rules of angles. So 180 minus 29 minus 40. Is 111. And then we will set up a law of sines to find side A. All right, sorry about that. So sine of 29 degrees over 15 is equal to sine of 111 over A. We will multiply those and divide by sine of 29. And that will get us a side. We don't need to inverse or anything. And A is 28.9. Now to figure out triangle A, or triangle 2, sorry, we did the supplement of the first angle we found. That was 140. As long as these don't go over 180, this triangle will exist. So let's just finish that up. We're in the home stretch here. Now it's just really number crunching. So to find angle A, we're going to have to take 180 minus 140 minus 29. And it's just a small 11 degrees, but it's okay. If you do the subtraction and it comes out negative, that's also a sign that you wouldn't have a triangle. You're never going to have a negative angle. And then to do side A, oops, little a. Make sure you use the information from triangle 2. So sine of 29 degrees over its corresponding side of 15. That was the B information. And then I have to use sine A and look for side A. Multiply those two, divide by sine of 29. (15) times sine of 11, and divide that by sine of 29. Looks like I forgot to use my alpha y equals. Please do that yourself. 5.9. And there's an ambiguous case with two triangles. The big thing is to get to that second triangle's information. A or B, the information that we started with stays the same. But that first angle that we find the supplement of it to find out what the obtuse angle in triangle 2 would be. Thanks for watching. Please complete the guided practice and the practice work. Have a great day.